Welcome back, Bolo people. Well, here we're kicking off the 12th installment of the integral Bolo knife series. Here we are at the Broadbeck Ironworks 2x72 grinder, and we are running a 120 grit ceramic belt VSM XK885Y, and we are just blending the edge of the frame to the back surface or the lower surface of the back of the bolster so that there's no discernible bump there. And we are being very, very careful not to hit the frame with the left corner of the belt, only just feathering it very lightly with the right corner of the belt. And I'm working a lot in the short unsupported section of belt at the top of the platen, as you can see, checking it with my thumb to see if it is as smooth as I want it to be. Here I'm going to the slack belt grinding attachment so I can just finish blending it even a little bit smoother. I like to do the bulk of the work with the belt more supported because you grind truer, and then maybe just a little finish blending just for scratch pattern on the slack belt attachment. And then I will go to a 220 J-Flex belt usually later down the road after this 120 ceramic. You can see me kind of rolling the frame back and forth, getting it from a few sides. I just need to be very sure that I'm not digging the corner of the belt into anywhere I want there to be a smooth blended curve. It's altogether too easy to do. You can see the knife is moving when it contacts the belt. When it first hits the belt, it moves throughout, and it's moving as I leave the belt. That way I don't get any dwell marks or corner digs. I get smooth sweeps on the edges of my shape grinds. Of course, we've switched to a J-Flex belt here. These are the Cling Spore J-Flex 309s, I believe. Nice and thin, flexible, cut pretty well on metal. I've ground a lot of finish bevels with them early in my career, and they do work, but they wear out quickly, so now I tend to use them just for blending on metal and then more heavily on handle material. At any rate, we're just kind of going over what we did with the 120, doing a lot of smoothing, lots of blending, getting 120 scratches out, making everything feel better. You know, really using the flex of the belt to kind of wrap a little bit into that corner notch. You can see me kind of feeling it with my finger there, see if there's a too sharp a corner. And this still may not be the be-all, end-all of the guard dimensions. I'm just kind of getting it nice for now, just as an intermediate step. Who knows, maybe I'll take it down in thickness later. I'm also making sure not to really round the corners off of my handle frame. I want a pretty square edge on the handle frame because I don't want an imprecise kind of like rounded over look where it meets the ivory later. I just want it to come up nice and flush to the inside of the ivory. At any rate, I'm just finishing off on the spine here. You can see me rolling it back and forth, and that is just to lightly dome the spine. We are going to not want a sharp corner on the edge of that on the finished knife. As a matter of fact, you can see me still taking a little bulk off the sides here. I think I mentioned before, I wasn't too crazy about the check etch pattern, at least regarding the sides of the guard. I thought the guard was still a little thick, a little heavy, needs some taper in front, and it needed to lose some weight to grind off more material to get down to the prettier part of the twisted W's pattern. It was still rather plain at the surface of the side of the bolster and guard when I check etched it. So we're grinding down a little bit further in there, see if we can get a little bit more W's activity to surface. But we're still making sure to do this evenly, and we're checking the sides of the radius transitions on the finger notch and the top corners of the bolster area as we go, making sure not to get any low spots that would be hard to fix later. Got to have that light on both sides to be able to see what you're doing. You can make a real big mistake on a crisp corner. I mean, if you grind a 1/16 of an inch below on one of those shoulders that face the ivory, like, there's no putting it back. You're going to have to grind everything down to meet that, and everything's going to be thinner than you wanted. So caution is the word. On the plus side, I'm getting a real good look at all of the weld surfaces around this integral composite guard blade junction, and the welds are just perfect there. Looks like clean steel until you etch it. That's what I like to see, and that's really what I found over time, that completely TIG wrapping that joint lightly gives me. I've done it, with blocks, with just oil, with a MIG tack in the back and no TIG, and always the cleanest results with the least forging happens with TIG for me. I don't even TIG all my tiles, but I TIG that. So the Broadbeck does flip on its side, and I actually haven't ground these guard scallops with a sideways grinder before, so I thought I would give it a shot rather than my normal orientation of holding the blade horizontal to the floor. Now I'm holding it vertical to the floor to grind that little scallop on both sides of the front of the guard. That's there as a stylistic choice. It's certainly not original to me. I think about Nick Wheeler primarily doing that back in the Blade Forums days of like 2010, maybe 2009. It just looked really cool. And a bunch of other guys have done it too. Not sure who did it first. I like it. Just takes a little weight out, gives a little style to the front of that, breaks up the otherwise rather boring straight line of the front guard face. Quick look here. So we ground one, looked about how we wanted it. Now I marked this up just with marker and used a set of calipers to find this width from the face of the guard back to the back of the scallop, and then transfer it. And then I used calipers to find the depth here, and then transfer that. And then I found a washer with the same basic radius as this, held it up and used the scribes to create a semicircle. So now I have a rough idea of where I want that scallop to be, and it's not a lot of guesswork and, making a four-legged table and having to cut 1/8 of an inch off of each leg until the table's a foot tall. If you get what I'm saying. Let's go for it. I think today I was listening to more of Dan Carlin's Hardcore History, Supernova in the East, Chapter 6 out of 6, the final chapter, 5 or 6 hours on the Pacific Theater, World War II, the denouement with fighting on the home islands of Japan, and ultimately the bombings of Hiroshima and Nagasaki. Very sobering stuff, but also very fascinating to listen to, and something that my mind can kind of really pick up on while I'm doing this sort of work with my hands. At any rate, check it out if you haven't. Dan Carlin's got a ton of other great podcast material to listen to about all eras of time. Switching to the 220 belt. And what I've done here for these is I just took the platen out of the platen attachment. So there's a unsupported belt section where the platen would normally be, and then I've leaned the whole platen back at the top so that the bottom wheel has projected out. That's a 2-inch aluminum wheel, and then I flipped it sideways, and so now I'm grinding with a contact wheel of solid aluminum, which works fine as long as you can see that I'm supporting my work actually by planting a finger on the top of that bolt as I go. Very nice to have an anchor point when you're doing detail like this, because as you can imagine, if you slip and you ride over the shoulder of a crisp feature you've been trying to put in, well, you could really have a mistake that would be hard to fix. Ask me how I know. So I'm putting a border line all the way around the bolster near where the handle will fit up to it. And I've made basically a mock-up border cutting tool. It's a piece of mild steel about an 1/8 inch thick for the handle and the body of the tool. And then there's a stack clamped to it with these C-clamps. As you can see, I have tape around the handles of the clamps so that they don't fall down and hit my work. So basically it goes handle on the right and then a standoff of whatever thickness corresponds to the distance I want my border to be from the back edge of the guard. And then actually cutting the border, the third piece of the stack, is a piece of portaband blade that I have clamped to the other side of the standoff. So I can feel that the back of the guard serves as a guide, and I can feel it as the body of the tool, which projects down a little bit, rides along it. Then the standoff puts the blade right where I need it to be to do the cutting. It's a pretty intuitive tool to use. You just need to constantly kind of recalibrate your hand to make sure you're not getting crooked to the guard. You can really feel when it indexes right there onto the flat, and then you keep going for a little bit. Cut around the corners. And it's actually kind of a fun process. This is an area of a knife where at a later date probably I'll be putting like gold inlay, which will show up nicely after the damascus is etched, but I also like how a plain line looks. That's where my level of tech and skill is at the moment. I do have an engraving set up, and I've done copper inlay, and it's pretty practicable, but I don't have the gold on hand, and it just wasn't within the budget and purview for this particular project. So you let the standoff tool with the bandsaw blade do most of the cutting for you and set the spacing, and then you come along with a few needle files and you clean it up, pretty it up, widen it up just a little bit, make it a little bit crisper as you go along. Might even seem like it was a little bit tedious to the casual observer, and it is, but at the same time this is a pretty fun part of it. It changes the look of the guard for the better, in my opinion, rather quickly, and it's just kind of a pleasant sequence of events. The guard is nice and soft at this point, and so it presents no problem whatsoever to cut with these tools. Now we're coming along with a little bit of 400 grit Rhino wet paper on a rubber backer just to kind of clean up the edges of it and make sure we're cutting clean. Any scuffs get removed and it just improves the look real quick. And we go back to the file and we're going to roll it around and flip it and do the other side. Because after all, this groove is going around the top, bottom, and both sides. What do you think? Have I managed to impress upon you yet the amount of time involved in putting in this little detail? This is all at 4x and 6x speed, and believe it or not, I did cut some of this footage. With the files, I'm taking the rough tooth cuts out of the bottom to get a more etchable surface, and I am also straightening up the sides and cutting everything to a uniform depth so you don't have shallow spots and deep spots. You want everything to look pretty uniform all the way around the corners, bottom sides, everything. So this was about it right here. I'm just going to have a look around the whole thing. You can see how that looks. Very nice taking it out of the vise and having a look here. Pleasing to the eye. I like those details. That plus the etching of the steel gives the guard enough visual interest. At least to my way of thinking. Alright. So now we are going to work on locating holes for the screws that will fasten the ivory to the frame. So you can see I used a particular block of micarta scrap there. It is flat. It is the right thickness to stand the scribe off from the back of the guard the amount that I want. You don't want those fasteners too close to the front of the ivory, too close to the ends, and you risk splitting, and plus it just looks weird. You always got to remember that the bolt heads are larger than you may remember when you're just looking at the frame and don't have the ivory and the bolt head right there in front of your eyes. You can't be getting the edge of that bolt head too close to the edge of the ivory. It looks bad and it's weak. So with that in mind, we're using the scribe here to set, or using the calipers here to set the distance from the edge of the frame as far as we can and still catch a solidly drilled hole and not be too close to breaking through on the inside of the frame. The most critical location being the top front hole, and then all of the others being set to that in terms of width from the edge of the frame. So once I got that top front one set, I lock the calipers and then I scribe that width onto the pre-blued areas all the way around the frame. I'm setting the offset from the edge first. I'm going to set the fasteners back a little bit farther than that from the edge and from the end of the handle to more accurately, or to more echo the spacing of the front one, the front set of bolts from the guard. So now I'm resetting the caliper to do that, and then we're going to scribe the other coordinate for the hole locations on the two end ones here. So those 2 on the end have full coordinates, the 2 on the front have full coordinates. And then usually I will fill in the middles by measuring with the little steel rule. I want the bottom screw to be between the front and back screw on the bottom edge, mathematically right in the center, and as well as the top. Now that will make them not be vertically coincident with each other, but that actually looks fine as long as there are lines within the guard and butt of the handle that are sloping away from that point. As long as the offset of the 2 center bolts is coherent with the rest of the design, it looks good. And it actually looks a lot better than if you made them vertically parallel with each other, but then had to mess with the center spacing of them in relation to the other screws, if that makes sense. If not, that's just word salad. Ignore it, and we'll continue on watching me punch these now. Sharpened up my center punch there. Don't look at the top of my welding hat. It's filthy. It usually stays in the shop. Oh, geez, I just mentioned it. Now you've looked at it. Well, at least don't tell anybody about how filthy that hat is, all right? Time to take it over to the drill press. Now here we are with a number 50 bit. Drilling it for 2x56 screws. So we're going to drill it now. We're going to countersink it. And we're going to tap it. Now, you can see here how careful I am to start these holes. I usually will start a hole dry, just so I can see where it is. Make sure the bit's not wandering. And then depending on what I'm drilling, what bit it is, etc., I will add lube. In this case, I just went ahead and carefully kind of pecked at them. And didn't do too much at one time. Got to make sure that little bit doesn't bind, so you got to just keep clearing the chips. I like to keep that little 1x42 grinder over there for quick deburring. Every time you drill one of these holes, it raises a little burr on the backside. If you drill another hole, it'll be off a little bit, often enough, because the part gets stood up a little bit at a slant because of that burr from drilling the last hole. So every hole I just take it, run over to the 1x42 sander real quick, do a quick little deburr. And once I get all these dudes drilled here in the nice soft handle frame, I'm going to go ahead and swap out to a small countersink. And just lightly countersink each of these holes on both sides. After I get that done, I'm switch back to the number 50 bit. And just quickly run back through each one of those holes, because the countersink itself will sometimes raise a little burr inside the hole. We want these nice and clean for tapping. Alright, so here is a reversible tap chuck.
No.
Broken tap. Change of plans. Alright, check this out, y'all. So this is an old drill press. I got it for like $5 because it was broken. The motor mount was broken. And so I converted it into being a hand tapper. It just has a simple hand crank on top. It's got the good drill press bearing, so it has a nice sensitive feel here. And this spindle has got a spring in it, which can be adjusted to give either down or up pressure. In this case, having some down pressure is pretty darn handy. So basically I have a a tapper here with a depth stop, some down pressure, a smooth feel to it. It's better than hand tappers I've used, quite frankly. And this is what I use for folders for the most part. So lock that there real quick. A little tap lube. This is slower, but hey, I switched to a brand new tap. And this is a more careful method. You can't afford any more breakages. Barely afford that last one. And you can use the hand crank on top if you want to run bigger taps. I'm just gripping the tap in the original Jacob's chuck for the drill press. But for a little tap like this, a lot of the time I'll just use the chuck body as the tap wrench handle, because I don't really want to be able to get very much torque on the handle. I need to have a very sensitive feel for how much pressure the tap is getting. The bigger of a handle I use, the more I risk of heedlessly and quite easily putting too much torque into the tap and just snapping it. And here I just back it off as a matter of course. Basically run a little tapping program in my head, quarter turn or whatever, and automatically clear the chip every time. The other thing I do is watch the flutes on the tap as I'm going. You can see them flex. They're always torquing back and forth a little bit. So as you get a little pressure on the tap, turning clockwise, you can see the flutes spiral flexing a little bit every time you advance the tap. You just need to make sure that that's a very subtle effect. Anytime I see the flutes stop cutting and start flexing only, that would be a surefire sign that I need to back way off, add more lube, come at it more carefully. But if you just kind of treat it as an automatic program in your tapping hand here, monitor it with your visual indicators, before you know it, you'll get down through there and be on to the next one. I'm gonna have to go up to my friend Nick's and EDM that broken tap out, because I'm not remaking this frame. And he'll be able to take a CNC lathe, machine a graphite electrode small enough and precise enough to discharge, machine that broken tap out without even screwing up the threads I was starting to put in. Alright, now we're all the way through. So I just run it down a little farther just to chase those threads, and we'll start winding the tap out. And we're good. So it's got I've already done one. I've done this one. I got to repeat that 3 more times, and then it's get this broken tap out. EDM is like the only way to get a tap that small out that's all the way through there. I mean, yeah. So here we are at the end of the day. Got a call back from my friend, and now I've got an appointment to go up there at 11 tomorrow morning and use the EDM machine to get out that one broken tap. You can see it there up in the end. All the other holes are threaded for the scale fastening screws. We got our little bit of file work in there, and the scallops cut into the guard. This makes everything look more detailed, more finished, more dynamic. We are just about ready for heat treat on the blade. fact, I think we are, and we would be ready for heat treat on the frame, but like I say, I got the EDM, that one tap out, rethread it, and then we'll be good on that. Here we are at my friend Nick Watts' shop, up out of Tonasket, Washington. A very interesting individual. He makes period correct ballistas, among other things, master machinist. Both worked for Boeing and then was self-employed for a long time, mold making, and this guy is a wizard with milling things. We're over on one of his two big CNC mills. We're using a little 5/64 end mill and very carefully pecking it down in there, a carbide end mill, to remove the remains of that broken high carbon tap. On second thought, Nick figured we'd better do it this way than try to EDM with such a small little piece of graphite, and I defer to his wisdom on that, of course. Another big beastly CNC mill there next to the one that we're using. You should see the rest of his shop. That's pretty nuts. These machines are 10 horsepower, I think, and 50 taper, or maybe they're 40 horsepower, or I mean 40 taper and 7.5 horsepower. I'm not sure. Either way, they got plenty of power, and we're using the high-speed head for this tiny little end mill.
A tenth of a thou per...
Oh shit, a tenth of a thou?
Every time I push the button.
I thought you said this thing had finesse. So now I'm sitting here punching the Z-axis and incrementally plunge cutting a few 10 thou at a time with coolant down into that hole. Well, we got the broken tap out and actually managed to salvage a tappable hole of the same size. So this is the one that had the tap in it. A little bit bigger on the back side there, but most of that hole is tapped. So we are all good. Now we just gotta be able to heat treat it and then hope that it survives that without warping too badly. That's the end of this chapter. Thanks for staying with me this far. Here's a quick look at how the frame and knife look together so far, and here is the mammoth ivory waiting to go on in the next installment. See you then.